Chapter 13, Section 6 in the 8th grade workbook is entitled Quadratic Functions. Let's go ahead and start with the definitions here. We're talking about what a quadratic function is. That's a function that contains a variable that is squared. So for lots of different sessions here, lots of different sections, we've been looking at lines. And in all those cases, the variable x was always single-powered, meaning it had an exponent that was equivalent to 1. Well, now all of a sudden, here's something else. When the exponent on x is equivalent to 2. And what we have there when the equivalent of the exponent is 2, when the exponent is 2, is a quadratic function. Now, what does a quadratic function graph as? Well, a quadratic function graphs as a parabola. Parabola is the graph of a quadratic function. A parabola ends up graphing as a U shape. It's either going to open up or down. That's a guarantee. It's not going to open left. It's not going to open right. It's a U shape that's either going to graph to open up or graph to open down. So again, we're talking about quadratic functions here. Quadratic function is a function that contains a variable that is squared, x, and then a parabola is the graph of a quadratic function, and again, that's going to make a U shape. Now, as far as the graphing procedure here goes, we go down in different topics of math, we will eventually learn how to look at a function, the function that's specifically a quadratic function, and be able to look at that equation and know how to graph it just by looking at it. We don't have that knowledge yet because that's later on down in your mathematical lives. So for right now, what you're going to be doing is graphing with the table method. And of course, we've already done the table method this year. When we did the section on the table method, it could have been anything. But here, that's this section on graphing here, we know everything's going to be a parabola. So we know everything that we're going to graph today with the table method, the result is going to end up being that U shape. So no question, unlike the one section earlier, everything's going to be that. So let's go ahead and go look at the first question here. Create a table for the quadratic function and use it to graph the function. And we've got f of x equals x squared plus 1. All right, so remember, in the table method, you pick your own x values, and they happen to pick my favorite list of x values here, -2, -1, 0, 1, and 2. We're going to plug each one of those in for x and find the result value, which is going to be the equivalent of y then, which I'm then going to pair my x and y and go ahead and make myself a graph. So let's start with -2. I'm going to change x into -2. -2 squared, that's equivalent of -2 times -2, which is positive 4, plus the 1 on the end here is 5. -1. -1 squared, -1 times -1 is positive 1, plus this 1 here makes 2. 0. 0 squared, 0 times 0 is 0, plus 1 is 1. 1. 1 squared is 1, 1 times 1 is 1, plus 1 is 2. And finally with the 2, 2 squared is 4, 2 times 2 is 4, plus 1 is 5. Now, I want you to notice here there is a little bit of a pattern here, which is not going to be uncommon when we graph parabolas. When we have x values that are opposite of each other, notice that the y values that result here happen to match up. And unless they do really something kind of odd with the function there, that basically is what you're going to see in pretty much everything you end up graphing there. So if we were to plot 3 and -3, we would expect that the y value would end up being the same. Indeed, 3, when I plug in 3, 3 squared is 9, plus -3 squared, -3 times -3 is 9, plus 1 would be 10. So as we see, going out, opposite x values there have resulting y values that end up being equivalent. All right, so I'm going to go ahead and connect my points now. I'm going to start off at the top, -2, 5. Means I'm going to go to -2 on the x-axis and up to 5 on the y-axis and put my dot. Remember, the x value always corresponds with the x-axis, so I did that one first. This value over here, the f of x, well, remember, as we talked about yesterday, that's equivalent to y. So that's going to match up with this line here. So when I do -2, I go to -2 on the x and then 5 on the y, put my point. -1, 2. Left 1, up 2, put a dot. 0, 1, not right or left, just up 1 and put a dot. 1, 2, right to 1, up to 2, put a dot. And 2, 5, right 2, up to 5, put a dot. I'm connecting my dots, and there is my U shape. Again, the U shape here, the parabola, always has to open up or down here. That's really the only way this is going to work. If you end up with something else, or a U that looks like it's opening to the left or to the right, something is very clearly wrong. All right, let's look at number 2. The function f of x equals negative 16x squared plus 96x gives the height in feet of a model rocket x seconds after it is launched. What is the maximum height that the rocket reaches? How long does the rocket stay in the air? So if I'm launching a rocket from the ground, right, it's going to have some velocity when it starts. So obviously the height of the rocket is going to increase. But at some point it's going to lose forward momentum. All right, and when it loses forward momentum, that's when it's going to come crashing back down to Earth here. All right, so that's going to end up modeling what is a U shape, because it's going to go up to a point, and then it's going to drop all the way back down. All right, and that's going to generate that U shape. So what they did here is they picked some x values. Obviously they started at 0, which is going to be really easy to figure out, because at 0 seconds it's not going to be any feet in the air. But they're going to go all the way down here through the list until we get back to another 0. Because when I get back to another 0, that means the rocket has hit the ground. And as you can see, that's why they've stopped here at 6. Because when we plugged in 6 in for x into the function here, we got a result of 0. Meaning 6 seconds into the trip, the rocket is now back at Earth level and it's not going to go any further. All right, so that's why we stop here at 6. Obviously, we want to do everything in between, because the question is also asking me for the maximum height, so I have to find the greatest value that spits out of the function here. So we start with 1. We'll change x into 1 and solve. So I've got 1 squared here. Again, I'm going to do order of operations first. 1 squared is 1, times negative 16 is negative 16, plus 96 times 1 is 80. So 1 second into the trip, the rocket is 80 feet in the air. 2. 2 seconds in, 2 squared, 2 times 2 is 4, times negative 16 is negative 64, plus 96 times 2 changes into 128. So 2 seconds into the journey, the rocket is 128 feet in the air.